Hello, everyone. Welcome to Edubbey Global Solutions. Today, we'll be looking at sense organs. Our senses are our ability to be aware of different aspects of the environment. We learned from the previous chapter about receptors. Receptor cells are often grouped with tissues to form a sense organ. I have a table here showing us classification of receptors. We have photoreceptors, chemoreceptors, thermoreceptors, and mechanoreceptors, and the type of stimulus they respond to respectively. So a quick question here says receptors in sense organs are transducers, that is, they convert stimuli to electric impulses. True or false? True. Moving to the next slide, I've prepared a quiz for us to solve, or like say a puzzle for us to solve. I have listed out the types of sense organs that we have and where to match them with their function. So here I have taste depends on chemical, that'll be the tongue. The here is referring to the tongue. And then I have sight depends on light stimulation, that'll be the eye. Then I have balance and hearing depends on the ear. Depends on the ear. Smell depends on chemical stimulation by the nose. This is detected by the nose. And then temperature, sensitivity, and touch depends on the skin stimulation. So let's check. We got all of that correct. We also have that. We also thought that the body has a sense of position. Each muscle and tendon sends information about how stretched it is to the central nervous system. Okay, so moving on, we have the eye as a sense organ. The eye is an example of a sense organ. It contains receptors. It also contains rods and cone cells on the retina, which we'll be looking at as we move on. So we have parts of the eye. We have the pupil, the iris, the retina, the cornea, optic nerve, yellow spots. It's worthy to note that the iris is the colored part of the eye, which can expand and contract to control the amount of light that enters the eye. So I have a question. It said, which part controls how much light that enters the eyes? That will be the iris. Let's check. Okay, moving on. On this slide, I have a label diagram of the eye. I have the iris. This part here is the iris. I have the lens. This is the lens. And then this dark part here is showing us the pupil. The pupil is transparent, but the choroid gives it the black color. And I have the cornea. This is the cornea. This part here is the aqueous anterior chamber, the conjunctiva, the sclera. And here at the back here, I have the optic nerve. The retina is located here. So, talking about accommodation, when we're talking of sight, the ability to change the shape and focal length of the lens to focus on objects at different distances is what is called accommodation. This ability depends on the elasticity of the lens, the eye lens, the existence of ciliary muscles, which are used to alter the shape of the lens, and then the suspensory ligaments, which transfer the effects of the ciliary muscles to the lens. When viewing a near object, the circular or ciliary muscles contract, reducing their circumference. Muscles can do their work only when they are contracting. If an action is brought about by the contraction of one of the muscle, another muscle must be present to bring about the opposite effect. When one of these pair contracts, the other one relaxes. The two muscles together are referred to as an antagonistic pair. So I have a quick question for us here. Says which part of the eye focuses light on the retina? From the previous slide, you can find out that it's the lens. Thank you. Let's move on. Here we'll be looking at muscles of the iris, muscles of how they carry out reflex. The intensity of light falling on the retina is controlled by the iris. It has an antagonistic arrangement of circular and radial muscles. So we have a diagrammatic representation here showing us muscles of the iris in bright light and muscles of the iris in dim light. In bright light, the iris are constricted. Well, you can see that the pupil here is constricted, and that's because of the radial and circular muscles. The radial muscles are relaxed, while the circular muscles here are contracted, causing a constriction. Here on the other side, you can see a dilated pupil and the iris here, the circular muscles here are relaxed while the radial muscles are constricted. So there's a question here for us that says bright light could seriously damage the delicate light sensitive cells of the retina. True or false? Yes, if not controlled. True. So we have a picture here showing us our eyes and another set of questions says which way gives the appearance of the iris in bright lights? Okay, just like we learned from the previous slide, it says radial muscles contract, circular muscles relax. In bright light, the radial muscles relax and the circular muscles contract. Let's check. That was correct. Okay, we have another activity here showing us the diagram of the eye. It says what controls how much light enters the eyes? That would be the iris, and that is labeled B here. Another question says which row identifies the structure of the octopus eye? Which row identifies the structure of the octopus eye? Um, I have l- numbered labeled figure of the eye, and I also have numbered label figure of sorry, a table of the pupil, corneal lens, and iris there. Which row identifies the structure of the octopus eye? Here, figure 4 here is the iris. Let's check. It's figure 4 the iris, yes. Okay, 2 lens. Yes, this is the lens. 6 is the cornea, and then pupil. Pupil number 5. So again for option D, which type of cell must an organ contain to detect stimulus receptor? Yes. A person's iris is damaged. What is the effect of this? The person cannot control how much light enters the eyes. Receptors do not produce nerve impulses in response to light. The person cannot focus light on the retina. This will be the answer. So with this, we come to the end of another episode of our series IGCSE Biology. Remember to check us out on www.edubbey.com for more resources and activities. Thank you.